In section 6.6, we're going to be talking about basic function operations and composite functions. So function operations, we're going to run through if I combine two functions f of x and g of x, what the basic rules are and how I can do that. So for addition and subtraction, for f of x plus g of x and f of x minus g of x, I'm just going to take both of those functions and combine them either by addition and subtraction, and I'm going to combine like terms. For multiplication, I'm going to multiply both functions together. Typically, this will involve FOILing, and again, combine like terms if there are anything to combine. Finally, with division, I would take both functions and divide them with each other. One extra stipulation here is that I need to make sure that whatever I input for x, my output cannot be 0 in the denominator. So this is going to lead into domains. The domains of the sum, difference, product, and quotient functions consist of all of the x values that are in the domains of both f and g. So I take the domain of f and take the domain of g and combine it together to give me the domain of my functions that are combined. Further, the domain of a quotient function cannot contain any x values that would make my denominator g of x be 0. So I need to make sure to exclude any value that's going to make my denominator 0 in any quotient function. So let's start with an example. Let's let f of x be 4x plus 7 and g of x be the square root of x plus x. First, I want to find f plus g of x, and I want to figure out the domain. So all I'm going to do here is I'm going to add together 4x plus 7 plus the square root of x plus x. Looking for any like terms to combine, 4x and x will combine. So my final function for f plus g of x is 5x plus the square root of x plus 7. To talk about the domain, I want to think about any possible x value I can put in this function. Since I have a square root of x, I need to remember from previous sections that I can't put a negative number in here. So my domain here is going to be any x value greater than or equal to 0. In the second part of this, I want to figure out what f minus g of x would be. And again, I want to figure out the domain. So now I'm going to take both of these functions, and instead of adding them, I'm going to subtract them. So since I'm subtracting this whole function, I want to make sure to bring the negative to both terms. I'm left with 4x plus 7 minus the square root of x minus x. Again, I have the same like terms I combined, but now instead of adding them, I'm subtracting them. So my final equation here is 3x minus the square root of x plus 7. My domain is going to be the same here since I still am dealing with the square root. My domain is any x value greater than or equal to 0. In another example, we have f of x being x squared minus 9 and g of x being x plus 3. First, I want to find f times g of x, and I also want to figure out its domain. So what I'm going to do here is I'm going to take both equations, but instead of adding or subtracting them, I am going to multiply them. And in this case, since I have two binomials, I'm going to be FOILing. So I'm going to have x cubed plus 3x squared minus 9x minus 27. Nothing combines here, so I'm all good. From here, I don't want to overthink it at this point. I don't see any radicals, and I'm not dealing with any fractions or a denominator. So there's no x value that I guess quote unquote won't work here. So my domain in a problem like this is just going to be all real numbers. For the next part, I'm going to take both of those functions and divide them. And I want to find the quotient function f over g of x. And again, I want to find its domain. So all I'm going to do here is I'm going to take my top equation over my bottom equation. So from here, and we're going to get more into this in the later chapter, I could simplify this equation further, but for my domain, even if this simplifies, I need to think about any x value that'll make my denominator be 0 in the original equation. So for today and for this unit, I'm not going to simplify an equation like this any further. I'm just going to put function f of x over g of x. I'm going to look at that and I'm going to ask myself, what x value will make my denominator be 0? Here I see if I made x be equal to -3, that's going to make my denominator 0. So my function is literally just going to be x squared minus 9 over x plus 3. And my domain is all real numbers except for x equals -3. So any number could work for my domain except for when x is -3. The last thing that we're going to talk about in this video is composite functions. So composite function kind of looks like multiplication, but it's important to notice that this symbol is a hollow dot. So when we're multiplying, it'll just be a regular dot like what you're used to seeing, but if you see a hollow dot, that means it's a composite function. And I want to read that, in this case, in this example, as g of f of x. And how I'm going to go about these is for whatever x value I'm given, I'm going to find f of x first, plug it into the f of x equation. Whatever output I get there, I'm going to use that in and plug that value in as the input for g. So how this would look like in an example, let's let f of x equal x minus 5 and g of x be x squared. And in this problem, I want to find g of f of -3. So what I'm going to do first is I'm going to find f of -3. So I'm going to plug it into my f of x equation. F of -3 would be -3 minus -5, which is -8. So now I'm going to take that -8 and I'm going to plug it into my g of x equation. My g of x equation is x squared. So to find g of -8, I'm going to do -8 squared, which is going to be 64, and that would be my answer. Now what's important to note is that it depends on the order that I say, like g of f or f of g. So now let's find f of g of -3. So the same input value to start with, but we're going to see how we get a different answer. So to find f of g of -3, now I'm going to find g of -3 first. So I'm going to do -3 squared, which is 9. Plugging that into f of x, which was x minus 5. I'm going to do 9 minus 5, which in this case will give me 4.